Welcome to this channel MathEnggX. This channel has been providing lectures on engineering topics. We had given many lectures, many video lectures on process control. We will see yet another lecture on the yet another lecture on process control. Before that, I request all of you to subscribe to this channel if you have not already done so. Please share this lecture to your friends, and if you have any comments, any suggestions, any questions, please leave it on the comments. Please visit the channel and click on the subscribe button so that you get to know whenever a new lecture is published. Well, so let us go to the topic. So today's topic is transfer function. Transfer function. What is transfer function? So transfer function is a mathematical function, is a mathematical equation or function which relates an input and output variable of a process or a system. Okay. It's a mathematical function which relates an input and output variable of a process. So let us consider a process. So let's consider a process and there is an input variable. Let's consider one input variable and one output variable. So this process at steady state, the value of the input variable is xs, the value of the output variable is ys. In other way, this process has been designed with an input variable of value xs, an output variable of value ys. So this is the design values xs and ys. So when the process operates at steady state without any disturbance, these values of these variables are xs and ys. So x is used for input, y is used for any output. Subscript s denotes steady state. So this is ys is steady state. So xs and ys are steady state values. Okay. Now let us consider because of some disturbance, the input variable begins to change at t equal to 0 onwards as a function of time. So this input variable begins to change as a function of time xt. The input variable begins to change because of disturbance as function of time. So xs, the input variable is x, at t equal to 0 onwards varies as x of t. So then what will happen? The output y also will vary as a function of time. The output y also will vary as a function of time. At t equal to 0 onwards, the input variables begins to change as a function of time xt. Then the output variable also will begin to vary as a function of time yt. So this time at which disturbance takes place, we make a reference that our reference point is t equal to 0 is at the time the disturbance starts. So after t greater than 0, after t0, that is t greater than 0, it is unsteady state. That is, the variable is changing. The variables are changing. unsteady state. T greater than 0 represents unsteady state. T less than 0 indicates steady state. T less than 0 indicates steady state. So at steady state the variables are xs and ys. At steady state the variables are xs and ys. At unsteady state the variables are x or x of t, x bracket t or y. You can simply write y here, you can simply write x. X and y are variables, whereas xs and ys are constants. Well, now let us define a new variable called deviation variable. That is for the input side. Let me define as capital X. Capital X, which is going to be a function of time, is defined as this x minus xs. Instead of x bracket t, we can also write as simply x. It is understood it is function of time. You can also write for simplicity x minus xs. So what is this? This is a deviation variable. Deviation variable of the input. Deviation of the input from its steady state value. Deviation of input x from its steady state value. So input deviation variable. For simplicity, let me call it input deviation variable. It's not exactly the input variable, but input deviation variable. Similarly, for the output, let me define as capital Y. Capital Y as uppercase y of t minus y of s. That is again, so this is output deviation variable. Value of the output variable, the deviation of the output variable from its steady state value. Output deviation variable. You can also write it as simply as y minus ys. So the lowercase letters represent the actual values at steady state and unsteady state. The uppercase represents the deviation value, the value of the deviation of the variables from their respective steady state. Capital X of t is x, the value at any time, minus xs, the value at steady state. Then we define the transfer function. What do we define transfer function? We define transfer function in terms of this deviation variables and in terms of Laplace transform. So transfer function is defined as, so this is the definition of transfer function. G of s. G is a symbol for transfer function. G is a symbol for transfer function. G bracket s. So this is defined as ys by xs. Capital Ys divided by capital Xs. Gs is the symbol for transfer function. So transfer function is defined as y capital Ys by capital X of s. So what is y of s? Y of s is Laplace transform of the output deviation variable. X of s is the Laplace transform of input deviation variable. So this is the definition of transfer function. So how do you describe this? So transfer function is the ratio of the Laplace transform of the output variable and the input variable. The transfer function is the ratio of Laplace transform of output variable to the Laplace transform of input variables. So not exactly the output variable, but the output deviation variables. What you have to consider is the deviation variables. So let me rephrase the definition. So definition of the transfer function is the ratio of the Laplace transform of the output deviation variable to the Laplace transform of input deviation variable. Ratio of the Laplace transform of output deviation variable to the Laplace transform of input deviation variable. So it relates the input and output of the process in a particular way through deviation variables and through Laplace transform. So that is what we said is a mathematical function which relates an input and output variable of a process. So this GS is characteristic of the dynamics of the process. It tells us once we know the transfer function, we'll know what will be the what sort of dynamics the process will have, what sort of response it will have for any disturbance. So the transfer function represents or is indication of the dynamic characteristic of the process or a system. It can be a process or it can be series of process. This can be a process or can be series of process, or it can be a system consisting of a process or many processes. So we'll be using these terms process and system invariably. So transfer function is characteristic of the dynamic nature of a process or a system. Now once we know, so for any system, any process, if we know the transfer function, the transfer function can always be found out by mathematical methods for linear systems. For linear systems, for nonlinear systems, it is not possible directly to find the transfer function. But for linear systems, transfer function can be directly found using mathematical methods. So once we know the transfer function, we can easily predict what will be the output or response of a process for a given input. So if there is a disturbance in the input side, if there is a disturbance on the input side, if there is a disturbance here at the input, then how does the process respond to this input? How will the process be going to respond to this disturbance? So you have to represent this by means of a forcing function. This is a forcing function on the process. Then find the deviation variable. Next, capital X, you find capital X is this is x minus x's. Take Laplace transform, you get x of s. Then multiply this x of s by gs. Multiply this x of s by gs. Gs is a transfer function. Then get ys equal to xs into gs. Then find the inverse of this. Find the Laplace inverse of this ys. Okay, here I should write it here. So xs into gs is going to give me ys. Actually this way, xs into ys is going to give me xs into gs is going to give me ys, and from ys I find y of t, and from y of t I can get the response. So this is the way of predicting the response for any given input by knowing the transfer function g of s of the process. So in the coming lectures, in your course process control, we will be finding out this exercise. We will be doing out this exercise. We will be finding out the response of a process or a system for different types of inputs. And also before that, we will be deriving the transfer function of some of the processes. So the process transfer functions of the processes can be derived by mathematical methods from the natural, using the concept, getting to know what, if you get to know what happens in the process, if we can describe the process by a mathematical model, if we can write the mathematical equations describing the process, then we can derive the transfer function of the process. So these things we'll be doing in the coming lectures, obtaining the transfer function of some processes. And also, processes can be grouped based on the transfer functions. Processes can be classified or categorized depending on the type of transfer function they have. So that also we will see in the coming lectures. So from GS, we can classify the processes into some categories like first order system, second order system, etc., etc., etc. Okay. So we'll be deriving the transfer functions, and then afterwards we'll be doing this exercise of finding the response, from a given input, from a given known disturbance or input. So given input, you write in terms of a forcing function, then take Laplace transform, multiply by the transfer function, and then take inverse Laplace. Okay. So x to x of t to x of s, x of s to y of s, and ys to it, and yt to small yt response. So that will give you the response, dynamic response of a process. So hope you have understood this concept of transfer function. If you understood, please share this lecture to your friends, and also, as I requested, please subscribe to this channel, because I think most of the people who view this are not subscribers. So it will be better if you subscribe to this channel. Please visit the channel and click on the subscribe button, share to your friends, and give your comments. So we'll come with more on the transfer function, processes, and dynamic response. See you.